Hello guys, now I'm going to check the backlash on the machine. I first check the X direction, I call this X direction, and the machine is turned on here, and so the X-axis ball screw is not moved because the X motor is was power on, and here I attach the dial gauge on the Z-axis, which is assumed to be stationary, and I pull on this pin that is fixed on the jaw, and the jaw is on the movable table, which is on the X-axis ball screw, and I pull it at a certain force and see the reading. This will count the clearance on the X-axis ball screws, as well as some errors due to the force applied on the upper half, the deflection on the upper half. And these deflections will reflect the deflection during cutting. During there is a cutting force, there is the total deflection by the cutting force in X-axis direction. Now the reading is 0 gram and 0 deflection. And this 3 kg, 4, 6, 7, 10, 13, 15, 17, and almost 20. There is one deviation, so 0.01 deflections. And notch it. Now it's -1 deviation. Now I start pulling. $20 is 1 deviation. Now is turn to the Y direction. Let's replicate. And Y direction is here. The ball screw is along this axis, and I attach the dial gauge on the Z-axis, and I assume the Z-axis actually will not move in y direction because they are perpendicular, and attach it to the z-axis motor housing, and the stylus touch on the jaw, milling jaw, and which is assumed stationary, and the diffractions will reflect the x-axis, y-axis ball screw backlash or clearances, together with the machine frames rigidities, errors in y direction. There's the whole bridge diffractions. I attach a pin on it. Actually it's 1/2 inch milling cutter here, but I attach the rope or belts on the collar. I'm afraid it will slip, so attach a pin there, and it's not clear on the dial gauge. Move the camera back to a little bit, and here set it first. And the reading is almost zeros, only a little bit less than 0. kg, 2 kg, 4. There is some diffraction there. Is 1 division at first, and I heard the motor sound a little bit. It seems the motors, the servo motors, have feedback. This 10 kg is 12, is 15 kg. There is a 5, there is 4 division error. Is a little bit more. I need to check where it's come from. And here I disassemble the cover. Let me put it far apart, far away. And this is the machine, whole machine. And on the left side there is cover. I take them off, and here the motors are revealed, and this is the bell. I squeeze it, and it is quite in tension. Maybe this bracket is not rigid enough. Squeeze it, the motor end a little bit vibrated. And the y-axis is a NSK linear actuator ball screw. Is a whole assembly linear axis, linear actuator. I still don't know where the deflections come from. Anyway, it's 15 kilogram pulling force. There is 4 divisions, or 0.04 millimeter deflections. It's now 10. It's now 13. It's now 15. And the reading is 6. Now go back to 2. And I think there is 4 to 5 division error. And I move this. I can move this. Let me check. I need a little bit vibrate. I put my left hand on the top of the Z axis and move it with 2 hands a little bit. It's better to put the stylus on this and on this milling cutter shaft and see the deflection, and attach the dial gauge on this jaw. Now as mentioned, that the stylus tip is now on the shank of the milling cutter, and the force go back to 0, and I start to move. It's a little bit less than 0. Is 7 kilogram, 10, 11, 13, 14, 15. Is almost 5 division. So it's 5 division. Under the force, 15 kilogram. Still same. And I move this a little bit vibrated. This is the accumulation clearance on the spindle as well. But the bearing on it, I replaced the spindle bearings with the NSK branded. This dial gauge is not a famous brand, but I think it's enough. I have the the Japanese brand, but it's a little bit larger. I don't use it at this time. So the right now is a little bit is 2 division 0.02. I think when I pull this, there is also error on the Z axis because the bending moment a little bit. Now I'm going to check the Z axis error or clearance backlash. The dial gauge stand is attached on the table. It's assumed stationary, and its stylus is the stylus touch the bottom of the collar, so it represents the movement in or diffractions in Z direction, and the rope is tied on the Z axis board, and I pull it in upward direction, and I only can screen make the wheels on the dial gauge only, and it is now 0 mark. Start to pull. I try to pull anyway, a little bit near the it's under the force 2 kg. 5 sorry, it's 10 kg, it's 13 kg. In 13 kg is 2 to 3 division. Try again. A bit difficult. Here. Hey! It's break. Oh shit. And I try again this bell to which break it. I attach the nylon ropes on the metal clip. Start it again. It's -1 division. Is 2 kilogram, 6 11, 12, 13, 15. It's almost 5 to 6. Try again. It's not 15. It's almost 4 division, and minus this 1 division, and there is 3 division error, not occurrence, 3 division. And the poorest is the y direction, is around 5 division, 4 to 5, and the best is the x direction. And Z direction is also bell drive, is here. There is 2 bell, and I squeeze it. I think this not very good, but not very bad. So thank you for your watching.